I would like to introduce myself. My name is Jay Schmidt, and I work here at MindWare. I'm a project manager. And I just wanted to let you guys know this is the webinar for BPV analysis. I'm also joined by some technical support representatives here who are going to be able to answer your questions. So if you do have any questions, please ask them throughout the webinar. How this is going to work is we're actually going to do 30 minutes of demonstration. And then we're going to finish up with 30 minutes of Q&A. And so any questions that you guys get will either be answered immediately if they're easy enough, or if they're more complicated and good for the group, then we're going to go ahead and answer those questions during that last section. Okay, so the first things we're going to do is we're actually going to look at some basic analysis configurations, some peak and trough editing, just sort of how to go through there, some techniques. How to deal with some noisy data. We have some edit points we can show you, and how to deal with them. We're actually going to export the data to Excel, show you what that looks like. We'll go ahead and make some edits to our file, and then we'll load that previously edited data file that's created. And then we'll just kind of show you some best practices and tips. Okay, so now we are going to go ahead and show you how to ask questions here. And so basically, if you guys look inside of your GoToWebinar little pop-down, you should see an option for questions here. And then you just go ahead and click that plus, and then it'll open up this dialog box. You guys can go ahead and type in some information and send it off to us. Okay, cool. So let's go ahead and get started here. So what we're looking at today is we're going to blood pressure variability. Basically, this is a tool to quantify variability patterns. We're looking at arterial pressure here. Why we're kind of using this. Blood pressure varies from one room to another. So even short periods of time, there can be some fluctuations there. We'll cover this a little bit in the next slide. And then again, we can just get a lot of information about the cardiovascular system in general here, just by looking at it continuously. Okay, so again, just to kind of go through this again, why are we doing continuous blood pressure? So this is sort of a snapshot looking at 300 seconds of some BP data. And so all of the peaks are recognized as the blue dots, and all of our troughs are the green for systole and distole. And so any sort of things that the algorithms have detected here are showing up as the yellow stars. And then we'll cover this a little bit here in a second, but this is the general layout. And so what I'm showing here is that we have a bunch of different beats within this 300-second, 5-minute segment. And if we look at, if you were to just take some sort of blood pressure from a normal monitor, some periodic blood pressure, let's say every 60 seconds, there's going to be a lot of information that you're missing and fluctuations there. So just another kind of benefit of looking at continuous blood pressure. Okay, so what we used and the data that we're going to look at today was collected using a CNAP blood pressure, a continuous blood pressure monitor. And this is what a lot of the our customers and that work with are using the same monitor. So just a little information on how this all works here. You can see that we use the normal cuff around the bicep here, and then it's going to take the measurement on that upper arm, and then it's going to complete an individual transfer function to the fingers. This is basically where the finger cuff goes on. And then we can know basically the differences in pressure between the two. And then finally here on the bottom, we can actually see the different waveforms depending on what site we were taking this from. And so obviously we're going to be looking at a waveform that'll much look like the number 3 here. Okay, and if anybody had any additional questions on the CNAP, this is an article that we've already created, knowledge base article number 12. You guys can find that on our knowledge base website, which is support.mindwaretech.com. And this will show you, again, just like it says, some step-by-step instructions on how to scale your blood pressure monitor with BioLab. And again, this is just we're gonna zoom in a little bit more to sort of look at the components of this waveform that we're looking at. So this is again what we thought we would see in the previous slide, and just showing the systole phase and then the diastolic phase there on the right. And then the most important thing is that dichotic notch that we're looking for. And so that's just kind of brief. And so now we're going to actually jump into the BPV analysis application, and we'll kind of go from there. Okay, so this is the BPV analysis application, and I will actually open a file as if I was opening it for the first time. So open this baseline file. So the first thing we're going to want to do is we're going to want to make sure that our channels are mapped correctly. And how we do that is we simply look at the label that we determined in Biolab, and we will go ahead and just marry that over to these channels over here. So ECG, you're going to want to make sure that's selected as ECG. Z0, we're going to get our respiration signal from there. And then our transducer module. So this wasn't labeled. I mean, I'd probably label this something else, such as like blood pressure inside of Biolab, but since we know that one's blood pressure, we'll change that to BP. And then our sync is going to be our event in this case. And we'll just hit OK. So this is the main setup screen, and as we'll just go through some quick settings here. File, basically if we need to go back and map that channel, or if we were dealing with a file that had two subjects. So if we pretend that these first 5 channels are the first subject, if you recorded 2 people in a dyadic experiment here, then these next 5 would be lit up. And so once we're editing here, and then we wanted to go and edit the second person, we can simply just hit map channels, turn these all to none, and then you would start mapping these appropriately. Okay. So that's what the map channels does, kind of an easier way instead of having to close out of the program. If you guys applied any sort of filters or scaling inside of Biolab during acquisition, or if you wanted to load this file back into Biolab post-acquisition, this is where you can actually make sure that if you want to use those filters, settings, you want to make sure that this is checked. Okay, finally we have settings configurations. So this is a very important part of all of our analysis applications, and even in Biolab, that I find very important. So what this is doing is, as soon as we have all of our settings here, our calibration settings, artifact settings, the video settings, what we want to do is we want to make sure that we save all of the settings so that we don't have to recreate that every time. Definitely, increase your inter-array reliability and such. So what we'll do is we'll simply come in here and say save configuration, and then basically every time you do, you would open up the BPV application. You come to settings, you say open configuration, and then it'll basically reset all of your things, and you don't have to worry about it. So I highly recommend that you utilize that. If you guys are having some errors inside of your analysis application, one good approach is to kind of reinitialize all to default. You can try to reload that configuration and then see if that'll help you with that. Finally, we have tools up here. So this is a ASCII file to a MindWare file. So if this was a file collected with an acquisition system other than ours, one of the ways you can pull this data in is you can use this text to MindWare file converter, and it'll walk you through there. Help. So this is going to, if your PC is connected to the internet, this will check for updates to see if there's a new version available. Every time you guys open up the application, it'll also do that check. We also have show help. This is extremely helpful, especially when you guys first get started. So if we click this and then hover over some of our boxes here, it'll give us something, let us know exactly what that is and what it's doing. And this is through pretty much the entire application here. There's also Control H hotkey for this if you guys want to turn that off. And finally, about MindWare, this will give you information about the version of the analysis application that you're using, and you can also see that I have a key plugged in, as we will need a key plugged in to run the program, and it'll also give you the serial number. So if anybody, if you were calling in for technical support, this would be some relevant information that we would need. Okay, so going down here to the data file path. Basically, what this is just showing where we loaded the file from. You guys can click this folder again to open that up, or you can go to File Open. As far as the file length, this is just showing how long our file session was, so 302 seconds. Modes, so we're going to actually look at these data in time mode. We do have many other modes available. There's event mode, there's different sub-event modes in there. There's also event in time mode here. So if you guys needed any sort of additional clarification or help on those different modes, you can actually check out this article here. Is a webinar that we did back in August. I actually did it myself. So this is the Applications, Events, and Modes webinar, and that'll kind of walk you through every single different way you could look at the data. But for today, we're just going to go ahead and look at it in time mode. And we're going to look at 60 seconds here. Okay, cool. So the next thing we're going to do is we're going to look at the BPV calibration settings. And we're just going to kind of walk through these and briefly explain what they're doing. So we have different ways we can look at the data and how we can scale them. And so there is slope intercept form, and there is map ranges form. You'll also find there's in the article that I brought up before, the knowledge base 12, I think it was. Yeah, knowledge base number 12. That'll actually show you the where to go and what settings and which one you should choose. And just so there's a note on this one, everyone's ranges are going to be different, whether it's the map ranges or the slope intercept here. So please see that knowledge base article on that. There's a picture inside the knowledge base article, but that's sort of just the default. So please read your manual on your CMAP also. Calculation method. So what this is doing is it's just kind of how we want to look at the data. So I'm actually going to jump into the analysis real quick, and then we'll come back to this just to show you what this is doing. So entire is basically going to use the entire segment that we're looking at. So right here we're looking at 60-second segments. If we were to break this down into interval mode, and let's just go ahead and leave it on every 10 seconds, what that's going to do is it's actually going to place these vertical white bars here, and they're kind of hard to tell. If we look at the one at 50 seconds here, you can tell 40, 30, 20, 10 seconds. And what that'll do is you'll actually be able to analyze the data within your entire segment. So we're looking at 60 seconds. And then it's actually going to also export a section with those different segments kind of parsed apart. So if you wanted to look at both, then you could certainly do that and then get some interval stats. Just takes off everything. Respiration signal that we're using. So as I said, when we were mapping the channels, we're going to use the Z-Naught. If you guys had a respiration belt that was also within the data set, then you could just select it from there. It's grayed out because I don't have one. Or we could use the DZDT, but we would definitely recommend that we're going to pull our respiration from the Z-Naught in this case. Points to use, just for the calculation here, we're going to use this distally just because systolic. We're going to use this just for a sharper point here, but you also have the option to use your diastolic. Down in the spectrum settings here, we have our windowing functions, and we have all of the most popular algorithms here for windowing those very low, low, and high frequency RSA bands here. There's also a knowledge base article on the respiratory bands here. So if you guys wanted to go to the support.mindwaretech.com site, you'll get some information there on what band settings you should choose. And we also have the some articles cited there for you. Finally, we have the baroreflex settings. So obviously one of the more important things we're going to be looking at for our researchers with continuous blood pressure is baroreflexivity. And so the three settings we have here for baroreflex events are change in blood pressure in millimeters of mercury, change in heart rate in milliseconds, which is 5, and then a minimum sequence of 3. So these are just our default values, but you're free to change them as you can see. If you guys had any sort of scientific questions, I would recommend a good place to start off would be the Handbook of Psychophysiology, which you can purchase through Amazon. So those are all of our BPV calibration settings. Okay, so now we're going to go on to the BPV artifact settings. We have 2 checks here, our little dip switches. We have an IVI min-max check, so that's just what that's going to do is it's going to look at the minimum and maximum time that's likely, physiologically likely, and if the beats sort of violate that rule, the rules that are set there within that algorithm, then it's going to mark those with a yellow star, which you guys saw on the previous slide, and we'll see here once we look at the data. So that's just the IBI, is just the timing between the interbeat intervals. And then the MAD-MET check is going to do kind of the same thing with regards to amplitude. So if there's some sort of spurious beat and it's very high, maybe it's motion artifact, maybe someone touched an electrical, something that plugged into an electrical outlet, then it could cause a blip in the data. And so this will sort of check for that, and if it's way out of the range, then it puts a yellow star, and then we know to look at the data closer. Finally, we have the maximum and minimum heart rate here. So again, this is pretty much the range that you should see for all of your human subjects. You can change this if you're doing a different species, obviously. And then obviously it could possibly drop below 40, especially if you're doing some sort of sleep studies or yoga or something like that. So just kind of keep an eye on that. The heart rate is one thing that you can easily mess up on, but this should cover basically all of the ranges that you're looking at for humans. Finally, we have additional settings here. So basically, if you have a MindWare system with the synchronous video and you save your video files along with your physiological data, when you pull up your MWI file or your MW file, it should automatically find these videos for you. If it doesn't, and this should be checked and it'll kind of find those. If it doesn't, we can simply uncheck that. We can click on one of these folders, go find a video such as this. We can actually set our delay here. If you had a video camera and it wasn't synchronous with the physiological data, but you did want to make it, you did want to synchronize it post-acquisition, then what you could do is you could come in here and set the delay basically down to the millisecond forwards and backwards. And then if we wanted that to appear on the analysis screens, we'll need to show the video. Cool. And that is all of our basic settings. So now we are going to transition into the analyses. So I'm going to hit Analyze. First check that we have here is the invert check. And we're basically looking for that upward inflections of that systolic upward inflection. As we can see here, we're looking at about the average is somewhere around 0.6, 0.65. And then we can see we have these large upward inflections all the way up to about 0.85. And so we can see that this was not inverted, so we'll say no. Okay, and now we'll kind of go through all of these different screens, and then we'll actually show you how to edit some of these data. So the first screen here is just our general BP data, and then we can also see that we have we have all of our blue dots. Those are the systolic peaks, and then we have our the green ones for the troughs, or the end of the systolic pressure. And basically what you can see here is bar reflexive vents, and they're shown as a sequence of cursors. And the purple ones represent the like an ascending BP sequence, so that's a lowering of the heart rate, so a descending heart rate sequence. The white represents basically the descending BP sequence, and so an descending or a faster heart rate sequence. So that's the difference between the purple and white that you're seeing on there. The next screen down is, oh, and then one more thing here, we'll see it again, but the little yellow X's that are in the middle of these data, those are our mean arterial pressure. The next screen down here is our IBI series. And so what we have here is we have time on the left in milliseconds, and then we have the number of beats, or your IBIs on the bottom here. And so a way to interpret this and sort of its use is that if there's some sort of large fluctuation with regards to time between beats, what we'll see here, so for example, we're at beat number 4. So 1, 2, and 4 look like it's slowly declining, but they're about the same time, about 800 milliseconds. And then it looks like from 4 to 5, it drops all the way from about 750 milliseconds down to about 350, which is pretty intense. So that's probably not correct. So if you looked here and then saw some sort of either a downward or even an upward that was pretty dramatic, you could kind of just follow that straight up to the scale BP screen here. And we can see that we have some yellow stars sort of alerting us that this is probably not correct, and we can look at the data. So it's just sort of a quick visual check to know if you need to go into the Edit Peaks and Troughs screen. Next one down here on the left is going to be our heart rate time series. And this is pretty simple here, but again, we're going to have, this is a dual time plot. So we have milliseconds on the left. We have time on the bottom, 60-second segment. You can see that we're still in a 60-second segment up there. And then we're just looking at the time in between, so pretty self-explanatory there. Just another visual check here. So somewhere around 4 to 5 seconds, and then anywhere from 11 to 16 seconds would be, or even as far as 22, would be something that we would want to look at. And that's kind of verified here in the data that we're seeing these yellow stars. So just letting us know we get to check on that information. Same with the blood pressure time series. And on the left here, though, we do have the millimeters of mercury, and then time on the bottom. Again, any sort of large fluctuation like this could be legitimate, but it could also mean that we need to sort of look at the data a little bit closer here and see if we need to edit anything. And finally, we have a respiration time series. Again, 30 seconds or 60 seconds on the bottom, which is our segment length, and then our volts on the left. One more thing we could look at here is that with those larger respiratory cycles, you expect the heart rate to increase and decrease depending on whether they're inspiring or expiring on the how they're breathing. So any sort of large inhalation here, you might expect the IBI series to decrease, or vice versa. So just another sort of check. On the right here top, we have our heart rate power spectrum, we have our blood pressure power spectrum, and we have our respiration power spectrum. So one key note here, which is somewhat apparent, is that on the left and top, we're dealing with the time. After we're going to pass these things through an FFT, we're going to actually go into the frequency spectrum, which is now these three here, the heart rate, BP, and respiration power spectrums. So quick note here, when we're looking at these and how these are determined, basically we have three segments that we're looking at. We're looking at very low frequency, and high frequency, which is also where we're looking at RSA. And so how these are kind of set is in the previous screen. So if we go back and we look at the BPV calibration settings, we see we have our windowing function, and then again we have these three bands, our very low frequency, and high frequency bands. And so we can see here, let's just take the high frequency, for example. We have 0.12 to 0.4 in hertz. And then if we look back down here again under our high frequency, which is yellow, you can't see the other yellow here because it's being taken up by the white, but so it will take up right here to right up about 0.4. So that's where those bands are actually being adjusted and set. So if you did want to change those, please feel free to on the previous screen. And then over here on the right, we have our statistical information. This will all be exported to Excel for us. And so it's just giving our statistics here, our mean systolic, diastolic, mean arterial pressure there, the mean IBI series, so 745 milliseconds, respiration rate, those are all going to be very important to you. You have your average BRS, and then the number of series that we have in the segment. We're also going to get all of these very low frequency, high frequency statistics and the ratios exported along with our frequency sort of information statistics here. Cool. All right, so now that we've sort of looked at all that, we're going to jump into the analyses, and we'll show you how to do some of these edits and some of the tricks and stuff like that. Okay, so just jumping back real quick. Again, I'm using these visual checks. I know I can see the yellow stars. That's a pretty easy one, and I can also see that my IBI series is maybe a little messed up here from the sharp ups and downs. So we'll kind of want to get rid of those as much as possible. And so just to begin with, we're going to kind of just, as far as what I want to do, I'm just going to go from left to right and sort of deal with these series on a case-by-case basis. So we're going to start from the beginning here. I usually like to use these tools. The second one here will kind of give you a good look at the information without jumping into it too much. So just to go through these here, this one on the left is our cursor bar selector. So as you can see here, we have the blue, or our X cursors. There's 2 of them. And then we have the green Y cursors, which there are also 2 of them. And we'll kind of go through some of the uses of these cursors, but this tool right here is how you select those. We also have the zooming functions tool. So we'll kind of jump through these real quick, but as you can see, this one right here is basically a window, so you would give it the actual aspect that you would like. It'll jump to that. This one right below it will actually zoom back out to show you the entirety of all the data. So if you zoomed in and want to get back out, that's how you do that. This one right here is what I like to use the most, and so that's going to kind of preserve the amplitude of the waveform. As we can see all of it, but it's going to let us zoom in and kind of go on the x-axis from there. We also have this other one, which will let you kind of do the same thing in the opposite direction. I don't feel this is as useful for this application, as we can see our peaks and troughs, but could find some use in it. We also have these 2 zooming functions here, which is simply a point and click, and it'll zoom into that spot or zoom in and out of that spot. Finally, we have the hand tool, so this will let you actually move through the data freely as you please. And so let's go back to normal. Okay, so what we're going to do is I'm going to go ahead and zoom in here, and we'll start looking at these data. Okay, so now that we're here, we're going to explain these top buttons here and how we're going to use them. So sensitivity, what this is going to do is basically, if we needed to delete one of these things, you guys can see that I have a yellow circle here, which is showing me where I'm going to delete either that peak or trough from. And if I wanted to make that larger, if you did have a mouse, you can simply use your mouse wheel to sort of you can get in there and snipe that little guy. Or you can, if you had a bunch of them in the same area that you needed to delete, you could do that. You can also just point and scroll that up there. Delete function, I think I just kind of went over that, but basically if we needed to delete any information, such as these yellow stars here that we can see that shouldn't be there, we'll simply go over both of those and hit the delete function. As soon as I do that, you'll see that it's going to find that this trough to peak time is good and make those the green and blue dots respectively. We have the insert, so if I needed to insert something that was missing, so let's go ahead and clean everything up here. Like that. If I needed to accidentally deleted one, and now I can see I have 2 yellow stars, but I know that there should be a peak there, then I will click insert, make sure that this circle kind of encumbers the entire peak, and then we're set. Now just a few notes here. So if we're inserting a peak, on the left here we're going to make sure that our peak is up. If we needed to insert a trough, such as down here, then we'll make sure it's on trough, and then click. Pretty simple. Okay, one other note here when you're doing this is we have a snap to peak function. So if I were to delete this peak right here and turn the snap to peak off, what it's going to let me do is it's going to let me put that point in exactly where I want, which may or may not be what you want to do. So just be a little careful with that. So you'll probably want to leave it on, but it's up to you. So if we leave that on, then it'll actually find that highest peak within the waveform and place it there. Mid-beat auto peak we're going to circle back to in a second. Set X cursor position. So let's pretend that I zoomed into a spot that wasn't on the screen with my X cursors. So something like this. What we can do is we can grab this. We can see which X cursor we're looking at if you have one on the screen. This is my X cursor low, so I need to find my high. But either way, we can put them both on the screen by simply just putting in time. So we'll look at the time plot on here on the bottom. We see that we're somewhere anywhere between 7 and 8 seconds. So let's pick 8 seconds to place our high one back on. Okay, appears that my number pad is not working, so that's not going to work. But if you did have a functioning keyboard, then what you would do is you would simply type in the number there that you need, and then this other cursor will appear back on the screen. If you didn't do that, then what you would have to do is you'd have to back out, go find where that is, move it to the window that you're looking at, and then zoom in from there. Okay, cool. So let's zoom back out a little bit, and then we'll kind of go from there. Okay, so that is how to move those around, setting the X cursor and the Y cursor. And then finally, we have the delete all points between cursors. And so what those are going to do is they're going to basically delete everything within there. So if I wanted to say delete all of these, I can just simply click this button and it'll get rid of all of those that are within there. Same with the Y. If we put those in, it'll basically delete all of the points on the entire, all the way down laterally. So we do want to be careful with that. Finally, we have remove data portion. I mostly suggest that this isn't used, but this is how you might use one, or this is how you would use it. Simply by clicking this, it's going to actually get rid of that signal completely. As you can see, that's probably not what we want to do. If we didn't want to use that data, let's jump back out here. If we didn't want to use that data for the statistics, what I would recommend is we actually delete all of the points between the cursors. And then we won't get any sort of messed up statistical information from there. Okay, so one of the next things we're going to do is we're just going to kind of go through here and clean some of these up. And so one of the features that I like to do is it's sort of a walking feature here. What we'll do is we're going to find some of the peaks that we know are good. So looks like we have some noisy data here, but let's go over to some of these good IBIs. We'll come in and we're going to take our X cursors and we'll actually place them over the systolic peaks. And then we can kind of just use this hand tool to sort of move backwards. Obviously, there's going to be some variability here, but if you had a lot of noise and you were trying to see which peak was what, this would be a good way to do that. And so we can kind of see generally, I mean, we can see that there's a peak here. This is pretty obvious here, that it's not this one lower, but again, should you have some more noisy data, then this might be pretty helpful. And so basically from here, we can see that this is just a little notch here that we need to get rid of. And so we'll simply come in here and hit delete. And then it'll turn everything back into the blue peaks and the green troughs. Again, here we're getting basically the algorithm is thinking that this following this tachytic notch here is another peak. This is incorrect. We'll just simply delete that, and then it'll reset everything. And then we're good from there. So that's kind of one easy way to sort of use that walking to, figure out what's noise and what's your actual peak that you're looking for. One of the last features that we're going to look at in here is going to be the mid-beat function. And so what we're going to do is we're going to take the left X cursor and we're going to place that to the left of the first known good beat. And then we're going to take the X cursor high and place that to the right of the known good one. We're going to delete this. Act like it's not there. We'll go ahead and delete our trough too. And we'll make sure that this is to the left of our trough. And then we'll simply hit mid-beat. As you can see again, my peaks and troughs is on peaks. So if I do that, it's going to find that and put there at the highest point automatically. If there was a bunch of noisy data and there was a bunch of spikes, then it's basically going to find that highest peak. So if we wanted to, we could also turn that mid-beat auto peak off. And when we do the mid-beat, then you can see it's going to place it in regards to time at the exact mathematical middle between our other two peaks. So that's not what we want here, obviously, because we can see our peak. We're going to want the mid-beat to be there. And as far as our trough, we can do the same thing here. In this instance, it's not finding the actual middle, so we're going to need to insert that automatically. But that's just as simple as hitting insert and then coming back over and then we're all set there. So let's go ahead and that's somewhere that you could place it. So just an example of that. And then reset is basically going to reset all of the changes that we just did back to how we want them. And that is sort of the extent of how to do some basic editing in there. One more note here. You guys will see the purple waveform that we have is the respiratory respiration, so our respiratory cycles within there. So once we're done, we can hit OK. As you can see, I deleted all of that data in the beginning. And so we're actually going to create an edited data file when we're done. And so at this point, you can click Done, and it'll ask us to create that edited data file, or we can write it to Excel. I'm actually going to write these to Excel, and then we'll come back and we'll create the edited data file. But so once we click on Write, we'll see that we have Create New and Select Existing. And so basically, if we create new, it's going to open up Excel for us and autofill all the data in. If we do select existing, if you had done this before, let's say you did a few segments, then you could go in, get that existing Excel file, and put in the segments that you missed on a later time. So we'll go ahead and hit create new. And you can see here it's filled in all of our statistical information. So just the time, the versions of everything I use, the sampling frequency, pretty much everything you guys might need to sort of report all these data, the Hamming function, the frequency bands, everything that we used. And then finally, all of that statistical information that we saw here on the right is found here. On the bottom here, we can also see we have other books available. So we have the IBI series, if you guys need to know timing on that per beat. The systolic and diastolic amplitudes, the mean arterial pressure information, heart rate, blood pressure, band statistics, and then finally our BRS statistical information. Cool. Okay, and so that is how we write to Excel. Finally, if we hit done, we're going to create that edited data file. And I'm going to go ahead and save this in my folder. And as you can see, for all of our different things, we have a .ed, so that's an edited data. If you guys are looking at it in heart rate variability, it's going to be a .edh. If you look at it in impedance, it'll be .edi, and so forth. So our edited data for our blood pressure is our EDB. We'll save that right there. And then one of the things we're going to demonstrate here is how to load that edited data file after we're done using it. So if you go to additional settings, we'll see that we have the edit settings available here. And so since I saved it within my same folder, we can see that we have all of our data here, and then we have our edited data, which is where our EDB is found. And then finally, we have the output, which is what we wrote from Excel. I didn't save anything, but and then we have all our other stuff like our video and our MW. You should have an MWI and MWX file, any events you guys had, user preferences. It's all saved within there, so that when we pull it back up, it should automatically find it. If it doesn't find it, or let's say you have your edited data file on a different location, you can simply check this, go find that edited data, and then we're from there. So we can just go in here. We can see that those edits are still missing. And that is the entirety of the demonstration. And so now what we're going to do is we're going to open it up the webinar for Q&A. So I'm going to place myself on a mute. So if anybody had any questions that they would like answered or shown to them, please go ahead and ask those questions right now. Okay, we do have one question here, which is basically about a bad chunk of data in the middle. If you had some noisy segment that happened in the middle of your segment, and whether you should basically just delete all the peaks and troughs or remove the data portion option. So we will circle back and I will show you. Okay, so if we do pretend that somewhere near the middle, actually I'm going to go back to the first time. So if we look at somewhere in the middle here, if there was a chunk, then basically To remove the data portion, again, I would always recommend that you keep the data because we can always just remove the data points and still see what happened there. To remove the data portion, it's going to be, I mean, we always preserve the raw data in the MWX file, but if someone were to make these edits and then show you something like this, well, it would be hard to be like, well, why did you do this? Everything is missing. So then you would have to go back and load the MWX file with, and then it wouldn't have any of their edits. So that's a little bit more time consuming and harder for, let's say the research assistant is checking and the PI comes and sees this. It's not great. So what we can do, I should hit reset. If there was some data in the middle, I would recommend that you use the delete all points between there. What that'll do is it'll give us good statistical information about all the rest of the information. It's just not going to use this middle portion. So if we didn't do that, let's reset this. Let's say that we deleted this middle. What it's going to do is it's going to think that from this first, or this left beat here, this systolic peak here, to this one right way over here at 34 seconds is one large interbeat interval, and it's going to throw all of our statistics off. If we were to just delete the points, it's not going to do that. There's a deeper issue here, though, with sort of information that happens at the middle. So the industry standard for RSA is we need 30 seconds of continuous data to get a valid measurement of RSA. That's just due to at least 3 respiratory cycles within there. So obviously you're free to do whatever you want, but just so you know, the 30-second rule, basically if anything were to happen around 30 seconds, it's going to invalidate basically this entire segment because we're looking at 60-second segments. So if anything happened right around here, it's obviously, again, your call in the end, but it would be probably proper to not use that segment in general. If something were to happen in the beginning of this segment, such as this, we could delete all of this information, and then it would basically start this first blue systolic peak and then move forward, and all of our stats would be good. So just kind of keep that 30-second rule in mind. Okay, we do have one question here about some noisy data and judgment calls and kind of what to do. The request is basically, do I have any really messy data? I don't have any on me, actually, really available, but I think we can kind of come in here and just make that up. So if we did have some, let me see. Get something. This is okay, I suppose. So as far as your waveform, I mean, this, you can kind of see everything. We can see our dichotic notch and our systolic peak and dystolic peak. So it's not very difficult. A lot of the markers, a lot of the things we can use, though, are going to be within our, that I'd recommend if you have really messy data, is going to be your X and Y cursors. And so, again, one of the functions that we can use to kind of deal with those really messy things is we can use that walking feature where we're going to line these up over the peaks of basically, so we're going to begin with a good complex, and then we're going to go forward. So I think I started here, so we're going to line them up, and then we're going to kind of move these over the next ones. We can see these are still pretty similar, not a lot of variability yet. And then we can kind of move this over and then start to see which is the good one. This is, I mean, that should be pretty easy and apparent, depending on how noisy your data is, but that's kind of a good way to do this. Another way we can also look at, especially with blood pressure, is we can look at our Y cursors. And so we can kind of put these over, just generally about where your peaks are meeting. I mean, you don't want to do this too much, especially with your diastole, but you can kind of put these around where the neighboring peaks and troughs are, and then that'll give us an idea of both the X and Y planes there and where that maybe that peak should be or that trough. Okay, we do have another question here about does the program automatically track how much artifact you have corrected in your file? To answer the question, unfortunately, no, it does not track how many or how much you have corrected. There's a lot of, we've definitely considered that within the applications. There's a lot of compounds that's doing such a thing. Within the culture, it's a very commonly cited, especially with such as like Gary Bernstein or John Castillo, but there's a 10% rule. So basically, throughout all of your data, if you're editing or sort of having to extrapolate more than 10% of the data for the entire file, so for the entire segment and for the entire file, then you would probably want to consider throwing that subject's data out. So basically, one thing you can do is sort of just sort of manually track it. If it's something that you can see very clearly, like we have the waveform here, and you're just inserting, like let's say you're deleting like these peaks right here, I wouldn't consider that anything like the 10% rule. It's very much when you're having to extrapolate or sort of guess where those peaks are, would you have to consider that part of the 10% rule. But yeah, so unfortunately you just have to sort of have your cleaners write down when they're sort of having to guess and estimate where those peaks and troughs are, and then just divide it. So one thing you can do, let's say here, if we were to delete this peak, so that's 1, and we do know basically how many series we have here, and so then we could just sort of divide that. So we have our, by the total amount there, and then we'll get our percentage off. So we basically just want to kind of keep within that 10% rule if possible. Okay, so we have a question here about tracking BP changes around an event, and how do we do that? So yes, we can do that, and I will show you how to do that. So this is again just asking us if we wanted to save the edited data, but we do not. So again, I am in time mode, and so if we're in time mode, we're actually not going to see our events. Our events are populated over here. Again, for additional information and clarification on this page and how to use events, please see our Events and Modes webinar. But just to show you here, simply we would come down to our Event tab. If we wanted, we could look at pre-post, event to event, stuff like that. Let's look at 10 seconds pre-event. A little short there, obviously. Okay, so let's post here. So what that's going to do is we can see here we have our event here on the left, and we're looking at we're looking at 60 seconds after that event. And these are all of the events that were kind of captured through the in-acquisition system and stimulus system, such as like ePrime. If you had events that you needed to do afterwards, then what you're going to do is you're going to load that file into BioLab, and then in there we have our event editor, which you can actually manually enter events. Let's say you had a video acquisition and you wanted to go back in there and say when they moved and stuff. You could simply put those events in, and then they will appear on this list so that you can look at those and the data at the same time. Okay, we do have a question here about TPR, or total peripheral resistance, and how we can get that information. So what we're going to do is basically we're going to import the BPV data into the impedance application, and then we're going to check the TPR box within that impedance application. So just so we can kind of see a little bit more what I'm talking about here, we have a knowledge base article. It's knowledge base 0039. And it goes through here with screenshots here and shows you exactly how we can calculate that TPR using the BPV output file. So what we're going to do is we're going to load it into BPV. We're going to do all of our editing, and we're going to export those results to Excel. And then we're going to load that same data after we're done into, we're going to load that same file into the impedance application, and then we're going to ensure that we have the Calculate TPR button checked. It's going to go through some settings here on what file output we're going to load. It's going to go ahead and give us a warning that it was detected in an algorithm, or it was edited in a analysis application other than one we're using. So you'll just click OK on that. That's fine. We know that information. And then from there, we can get the uniform pressure and TPR on our impedance application screen. So this is knowledge base article number 39 here. Okay, so we don't have any further questions, and it is 1:30 Eastern Time, so we are going to end the webinar for today. I just wanted to thank everybody for attending. We really appreciate everyone's feedback. So if you could, please go ahead and you're going to get an exit survey, and please fill that out. It'll help us make these webinars better in the future, everything like that. So Once again, thanks for coming, and we'll hope to see you soon.